Welcome to physics class. So we have an object projected upwards as shown on the diagram, and then it hits the ground. As it hits the ground, it bounces back. As it bounces back, it reaches a certain height, and now the graph shows everything. So this is the path of the graph as point A, point B, point C, and at that point we have point D and point E. Point E, then that's T0, that's B, that's that part. Those are the positions for the time. So those are crucial positions. Velocity, we have negative 8, positive 60.6, and 0. And then we also have there, and then we also have negative 12. And then time T, and that's 0, and that there, and then so that's the time positions where we look at the time on the graph. So these are crucial points to consider. And the magnitude of direction of initial velocity, so which means initial velocity will mean that our T0, and then that's the path of the graph. So that's the real graph we're talking about. So we look at any point that links to that part of the graph. So that's T0, T1 at B, we have T3 at C, and then we have T2, T3 at D, and then T4 there. And then from there we answer the question. The question says initial, so it's T0. So T0 it's negative 8. So looking at negative 8, there's T0. It projected upwards, so which means upwards is taken as negative and down is positive. So our coordinate will mean that down is positive. If down is positive, then up is negative. So down is positive. So we need initial velocity as it was projected upwards. So upwards would mean that we look at the initial path. Then we have upwards at negative 8. So it's negative 8 meter per second. Then we need to indicate the negative. What does it mean? It means it's downwards, it's upwards. So it's 8 meter per second upwards. As we said, down is positive, negative means it's going up. And then describe velocity at 7 seconds. 7 seconds is point C. C is equivalent to 60.6 meter per second. And then the next said use the graph to calculate. So that's it's positive, so it means that it's downwards. And then 2.3 required us to calculate the magnitude direction of the acceleration in the interval 0 to 7 seconds. So at 0, what would be our answer? So our acceleration is change in velocity over change in time. And then looking from 0 to 7 seconds, let's write the coordinates first. So at 0, when time is 0, our velocity there is x, and then that one is y. So at 0 we have 0 there, and then our initial speed is negative 8 meter per second. At 7 seconds, 7 there, that's going to be 60.6, which is our y value, x and y value, so x and y value coordinate. Then and we have at 7 seconds, it's going to be 60.6 meter per second. So that is T1 V1, that is T2 V2. So acceleration would be change in velocity, which is V2 minus V1, change in time, which is T2 minus T1, and that will be equivalent to that will be V2 is 60.6, V1 is 0, V1 is negative 8, so that will be T2 is 7, V1 is 0, so negative times negative is positive, so it's going to be 68.6 divided by 7, because 7 minus 0 is 7. So using a calculator, that gives us a value of 9,8 exactly, which is the gravitational force. So in v versus time, the gradient is acceleration, so the gradient becomes our acceleration, so a change in v and a change in time. And then let's look at 7 to 7.2 seconds. Once again, at 7 we have the values there. 7 at 7 we have 60.6, and then at 7.2, let's go back to the graph. It's going to be -12. So at 7.2 we have -12, so it's going to be -12. So -12 there, that we have T1 V1, T2 V2. And once again, we're going to use our change in velocity, so that is V2 minus V1 over change in time, T2 minus T1, to give us T2 is -12 minus 60.6, that negative plus negative give us negative value, 7.2 minus 7. So the top one gives us negative 70.0.2, and that is going to give us negative 363 meter per second. So negative, remember, is upwards, so meter per second squared. So that means that our acceleration is going to be 363 meter per second upwards. So that's what, because remember, negative means upwards, so positive means downwards. So negative there means acceleration is upwards at the value of 363. So that's our answer for 2.3.2. So we go on and calculate 2.4. So 2.4, it says calculate the time taken to reach B. So B from which point? From T0 to B, and then we don't know the time taken there. So which means we use this equation where it says final velocity is equals to initial velocity plus gravitational force multiplied by change in time. So we've put on the coordinates correctly. Final velocity there, at final velocity at that one, which means that at T0 final velocity, remember the velocity is 0 there at B, and then okay, so which means velocity, we have initial velocity was -8, and then our G, it has to be positive. Remember we said downwards is positive and change in T. So we take the -8 to the left hand side, so that will give us negative and positive 8. So that will be positive 8 is equals to 9,8 multiplied by change in time. Then we divide both sides by 9,8 and also 9,8, and that cancels out, so it gives us a value of change in T is equals to 9,8 divided by 8. So should give us close to 1, so that's 0.82 seconds. That's our answer. Thank you for watching, and don't forget to subscribe or follow. Thank you.